welcome everyone to the first Tech Talk of the year and the very first Tech Talk that is hosted by the ALASCA Association. I will say a couple of words about the history of the Tech Talks in a few seconds and how they made it to the ALASCA Association and what the ALASCA Association exactly is. But before we start with this content, I would like to say first that the session will be recorded. It's already being recorded right now, just so that you're aware of that, and we will just upload this recording on YouTube so that other people who cannot join today can still access the Tech Talk and the content that we discussed today. The second thing is that the Tech Talks are usually moderated by Marius Feldman, who is the COO of Cloud&Heat and also the chairman of ALASCA, but unfortunately today he cannot make it. So yeah, I will be substituting for him. My name is Maria Vaquero. I'm in the business development team at Cloud&Heat Technologies. And yeah, I'm very happy to be presenting and moderating today. So I will just start with a brief overview of the agenda. As I said, I will just provide a very short introduction so that the people who join us for the first time, or also those of you who are wondering what changes we made, so that you have a very clear vision of what we're doing here. Then we have the main content block of today's session, the Tech Talk, and followed by a discussion, which will be on the topic of Yaook, which is a lifecycle management software. And then we will wrap up with some news and events that we thought might be interesting to you. You're also welcome to share with us, anyone in the audience, any news or any events that you think might be interesting to the rest. So if you have anything in mind, just make a small note and we will open the microphone at the end. First of all, a very small recap. We started with the Tech Talks last spring. The origin of the Tech Talks was that there had been a group of organizations and companies that had been working together on a proposal for the IPSIS, a large European funded project on cloud infrastructures and services. And we realized that independent on the outcome of this project, we wanted to keep the discussions going and to share with each other what we were working on. And that's how the Tech Talks were born. So the idea was to have an open platform where everyone can present a technology or a project idea that they have, and the rest of us can participate and discuss. Cloud&Heat volunteered at that time to host the Tech Talks, and since then we had I think 6 sessions in total on different topics, software, use cases that run on the cloud, also some integration with other sectors, so a very different kinds of topics, and it's been very enriching. And the idea remains the same from now on, but the Tech Talks will be now hosted by ALASCA, which is a new association that I will briefly present right now, instead of by Cloud&Heat. But the main goal of the talks remains the same. So what is ALASCA? You might be wondering, why do they write it with a C? So ALASCA stands for the Alliance for Sovereign Cloud Infrastructures. So the C is for the cloud. And the association has 2 main objectives. The first one is that, well, we realized that there's when companies are looking for an alternative to hyperscaler clouds, they often lack the tools and the guidance to implement them. So the first objective of the association was to develop open source cloud projects, or to help further develop these projects and to provide some guidance on how to apply them. The first project of the association is Yaook, which is the lifecycle management software that will be presented today. And the second objective of the association is more related to the building of awareness, education, creating room for discussion on the relevance of digital sovereignty and open infrastructures. And when I say we, I mean the 7 founders of ALASCA, which are, besides Cloud&Heat, also Cyberus Technology, D3TN, DNation, SecuNet, SecuStack, and STACKIT. So if you want more information on the association, just visit their newly launched website or like the LinkedIn profile, and then you will see all the information that we have. Yeah, so you can get more information there. So with this introduction, then I will move on to present today's Tech Talk. We have two speakers today, Jonas Schäfer, who is a DevOps engineer at Cloud&Heat, and Ithisham, who is a cloud engineer in STACKIT. They have been both working and contributing to Yaook. Jonas is actually also one of the founders of the project, and they are going to present how Yaook works and how it uses Kubernetes to deploy OpenStack, which is a non-cloud native application. So without further delay, I will just stop sharing my screen and hand over the floor to you, Jonas and Ihtisham.
Okay.
Right, no, sorry.
Now I need to set this up. Quick confirmation that you see slides, and only slides would be much appreciated.
Yes, we see your slides.
Excellent. And also only slides. That's the other important bit of information. But okay, yeah.
Now it's gone.
No, yeah, it's gone again.
It's gone. What did I do? What did I do?
Yep, it's back.
Probably I accidentally hit the stop share button. Let me try not to do that again. Okay. Yeah, hello. Thank you all for your appearance. Today, we will give you a brief introduction about what Yaook is and why we are deploying a non-cloud native application on Kubernetes, which seems like a weird thing to do. And let's go over the quick outline here. After a quick introduction, which we will redo on the next slide, we will talk about what Yaook is, what the Yaook project is, what we are doing there, how and why we are using Kubernetes to run a non-cloud native application, despite not actually running in the cloud. We are running Kubernetes on bare metal, so having the cloud isn't really a good reason to do that, but we have other good reasons. What the practical benefits are compared to classical lifecycle and configuration management, for instance, Ansible, Chef, Puppet, SaltStack, and all the likes. And then a quick outro. Real quick introduction again. My name is Jonas Schäfer. I'm DevOps engineer with Cloud&Heat and the team lead for the cloud infrastructure development team, which is responsible for creating all the automation we use to deploy our clouds. And my lovely co-presenter is
Ihtisham. And yeah, I'm a cloud engineer at STACKIT and also a Yaook developer.
Right. And yeah, we will split the talk roughly in two halves, and I will start with the first half. Brief explanation about what Yaook is and how we are running complex things on Kubernetes. Maybe one or two more words on the context. So I'm assuming that most of you don't know what OpenStack is. Most of you have heard of at least about what Kubernetes may be, and that you can use it to run things easily, especially things which are so-called cloud native. So they are kind of made for being run in Kubernetes or Kubernetes-like environments. Real quick introduction what Yaook is in less than 3 minutes. I'll try anyway. First, we need to know what is OpenStack, which is what we are deploying with Yaook. So Yaook is an abbreviation for, sorry? Oh, I heard some noise there.
Yeah, I think it was just a hello from someone joining.
Okay, yeah, please don't hello when you join later talk. It's really confusing. So Yaook is for yet another OpenStack on Kubernetes, so a way to run OpenStack on Kubernetes. OpenStack is a complex piece of software consisting of lots of Python code, some as old as the early 2010s, dozens of different components, databases, and message queues, all of which are interacting together. It's a piece of software which allows everyone to play cloud provider. So for instance, offer virtual machines to people, virtual networking, and the kind of stuff. So think of it as being your own virtual data center provider. I was about to name a brand, but let's not do that. And OpenStack as such is extremely stateful because you have all of this customer stuff running or user stuff running there, like virtual machines, networks, which are configured, network components, virtual network components, which are running, all of this, which you don't want to disrupt whenever anything happens, because customers are really unhappy about their VM or network being interrupted. So we call this a data plane disruption, right? So when a thing which is already running, which doesn't have to be configured any further, is interrupted, that's called a data plane disruption. In contrast to a control plane disruption, when just the API you use to provision something is down. That's bad, but not terrible, because the things which are already running still work. But when the data plane is disrupted, that's really, really, really bad. So Yaook is a tool to deploy all of OpenStack into Kubernetes and orchestrate it the Kubernetes way. And to understand why we are doing it that way, let's talk about where we come from. So we come from classical configuration management. Think Ansible, Chef, Puppet, Salt, or even DebConf, if anyone knows what arcane tool that is. I assume most of you have heard at least one of those names. These are tools where you feed like a set of instructions in and maybe a bit of configuration, and then they do stuff when you ask them to do it, at best periodically, but most of the time they are triggered manually. And then they execute these instructions. Most of these systems claim to be some kind of declarative, like they use declarative language. For instance, when you want to install a piece of software, you write something like package nginx and then state present, as if that thing not being there would make nginx magically be absent, but that's not the case. They lie to you about that, which is really unfortunate. You can write state absent, so then it's gone. But if you don't write anything, there's no statement made about whether nginx is actually there or not, which is one of the downsides Ithi will explain in more detail later on. And this classical word of configuration management, where you have manually triggered stuff which looks declarative but is really a list of imperative stuff, that's where we are coming from and what we are deploying OpenStack with. And the question now is, why would we choose Kubernetes to run something so inherently complex and stateful if Kubernetes is made for applications which are mostly stateless, which are like APIs or something which talk to some database, which is elsewhere, where we don't talk about the state, something which you can just throw away and redeploy without any impact. The reason is that Kubernetes handles a lot of things automatically for us. Most importantly, rolling upgrades. So if we deploy a new configuration, Kubernetes takes a lot of the work away from us, making sure that the new configuration doesn't break anything, because it has these rolling upgrade mechanisms for its primitives for deploying workload. And also automatic failover to some extent anyway. With statefulness, you have to be a little bit more careful. And with these basic primitives and the customizability Kubernetes gives you, you have a very powerful orchestration platform. And then you only need to take care about the stateful things, like VMs customers may have in your OpenStack, or virtual network routers, or all of these components you don't want to have disrupted without your consent. To understand more what we're doing here, we need to understand what Kubernetes is in a nutshell, really. Kubernetes is an API, and that API talks to your nodes, which are worker nodes, and on those nodes, which may be virtual machines or pieces of hardware in a data center directly without any virtualization, you have these kubelet services. Those talk to the API, and the API tells them what kind of stuff to run on the workloads. And then there's also a database, the etcd, and the controller manager, which does things. And this is really high-level overview, and you don't need to understand the details of this, because what Kubernetes really is a control loop. And the classic theory of control loops, like your heating at home, where you have like a thermostat which checks the temperature of your room, and if that goes below a certain threshold, it starts the heating engine, and when it goes above a certain threshold, it stops it. That's what Kubernetes is in its core. You have the API and all the fancy data store stuff, and then you have a bunch of controllers which watch the status, getting updates from the API, check if the status matches the specification, and if that's the case, that's fine. They wait for the next change. And if the status doesn't match the specification anymore, they update in some way. For instance, by making API calls against the Kubernetes API to instruct other things to do things, or by modifying external state directly, for instance, creating a user or starting a service or deleting something. If the status is, it should be deleted. And that is really all what Kubernetes is, down to even the functionality of kubelet. If you know more about Kubernetes, even the things which schedule pods and which make sure that pods run on the machine they should, or provide volumes or secrets or whatever, all of this is just control loops. It's control loops all the way down. And this is a really powerful principle, the controller or operator concept. as I said, even just the most basic Kubernetes functionality is just control loops. And then Kubernetes allows you to add your own control loops in the form of custom resources and things which use those custom resources. And that is how we go about for deploying a complex and operating also a complex stateful application like OpenStack on Kubernetes. We create custom operators, think control loops, for each of those many components I talked about, the different APIs, the databases, the message queues, and so on. They all get their operators and custom resources. And then those operators take constant watch that they are in the right state. And they can also control things like tearing down a workload. So if you go ahead and say, kubectl delete this database, then, well, database is probably a terrible example, but let's say we want to remove a compute node from our cluster with VMs on it. Then the operator can do magic stuff, which Iti will talk about, and highlighting the advantages of a classical configuration management. So all of this allows us to do operations as code in a really powerful way, much more powerful than all the classical systems can do, because the classical systems only run when you trigger them, and they can't really react to state changes. Especially hard it is to react to state changes on other nodes. For instance, you are doing a rolling upgrade and then a node breaks and then your availability guarantee is not fulfilled anymore. And you want to actually hold the rolling upgrade for a while until this node is fixed. All of that, it's really easy to do with Kubernetes, which was hard to do with the old way of doing things, the classical LCM. And with all of this framing and explanation what we are doing and how we are doing things, how we were doing things and why we chose Kubernetes, I would like to hand over to the second part of Iti, who was so kind to pull some of the operational experience the STACKIT has had with running OpenStack in Yaook on a larger scale, and how the Yaook way addressed some pain points of the classical configuration management. Stage is yours.
Thank you, Jonas. So basically in STACKIT before, we were running OpenStack with Yaook. We used the classical management lifecycle tool. And I would share some problems there we had using and the reasons behind why we worked on developing Yaook to solve those issues. I'll just give, before jumping into the pain points, I will give a short intro to what our previous solution looked like. We used Salt, specifically the reclass model of Salt. And the way it works is you have 3 layers. You have the cluster layer, where you have production, staging, and dev. Then you have the system layer, where your OpenStack control services, control plane is deployed, or each of the services are deployed. And then you have the service layer, which contains the packages, the individual packages that are needed by these OpenStack services. And all of these layers consist of classes. And these classes are built up of a set of parameters. And you're basically importing classes from bottom to top. And the upper layer overrides the parameters that are in the lower layer. So in the end, what you get is a large set of parameters that are merged. So all of these 3 layers are in the end merged, and you get a large set of parameters, which basically ends up in the Salt formulas, which are below this service layer that you can see here. I won't go into detail of how Salt specifically works, but this is the model that we were using to deploy our OpenStack. So for example, if you are configuring Nginx for a Keystone, which is the authentication service of OpenStack, and Noah, which is the computer service of OpenStack, you would be using Nginx. And each of those will be, the Nginx class will be imported in Noah, the system layer, and also in the Keystone. And to configure those in your prod environment, you would have to import both of these in the Keystone and Noah into the prod class, and then you can configure Nginx by overriding the parameters. Now moving on to some of the difficulties that we had with the solution. So the complexity of the reclass model. And as you saw in the previous example, you are dealing with multiple inheritance. So you are inheriting the same class from the bottom to the upper layers and multiple times. And multiple inheritance is hard to deal with. And there is no easy way to solve it besides that you must be careful of the order of the inputs that you are doing in your upper layers, so that the parameters merging doesn't get mixed up. Besides that, you have common parameters between your different clusters that are applied to all the clusters and are being overwritten in different places, which makes it quite hard for you to find out which parameter is being set where and what is the eventual value that will be used in the salt formula at the end of it. In Yaook, in the contrast, it's quite different. You have Kubernetes resources, and you are basically, for each OpenStack service, you are defining a set of parameters individually, and they are quite well decoupled. So there is no configuration that is combined between these different services. Moving on to the next pain point. So upgrade and maintenance is quite a common task if you are working with OpenStack. And by maintenance, I need the maintenance of the compute nodes. If you have many compute nodes, it's quite regular that you would come across a compute nodes which fails, or you would like to upgrade them or do some other operational activities with it. With Salt by itself, or the reclass model that we were using, you don't get any tools around it to help you with that. So you have to write your own tools for that. And if you would like to redeploy a node or upgrade a node, you would have to use your own tools in combination with the Salt to redeploy them. The advantage of Yaook here is that it's quite interactive with Kubernetes. And we are using the operators, they can talk to the OpenStack API and to the Kubernetes. And this helps you combine the features of upgrading the nodes or maintenance and gives you an automated solution without having to take care of it outside of your lifecycle management tool. In this, coming to the second point here, in case of traditional configuration management tool, you aren't really sure if the update of the config that you are rolling out will work out as expected or not. So you don't know if the service will be functional after rolling out the changes, or you would have some, or the service won't respond anymore. For that, you would have to rely on your monitoring basically to figure that out. And as Yaook is basically based on Kubernetes, it solves your problem by making use of liveness probes or readiness probes. So whenever you roll out any change for let's say a stateful set or a deployment, it won't roll out the change on all the replicas simultaneously, but it will do a rolling upgrades or rolling release, and it will make sure that the first stateful set or first replica of the deployment is successful after moving on to the next one. And you can set a valid liveness probe to make sure that your changes doesn't hurt the service. Moving on to the next slide, non-declarativeness. So in traditional config management tool, you don't keep track of the resources that are deployed on a node. The management tool isn't aware of what is deployed or what is not deployed on that node. It will just add those things, or it will update the config there. If your services that are deployed there support disabling the service or disabling the resource, then it can do so. But the problem that arises here is that it can't really delete any of the services or resources cleanly. So you would have to disable them or go to the node and delete them manually of all the configs, all the resources that are deployed by your management tool. In Yaook, with operators, we are keeping track of all the Kubernetes resources that are deployed based on labels. So any update or deletion, the operator knows about all the resources that it needs to keep an eye on. And that solves your problem of keeping track of all the references that you have deployed with your tool. Moving on to the next slide.
This meeting is being recorded.
Okay. This lastly, but it's quite a major one for us, that we had previously our control plane services deployed on a single node, and we had replicas of it, but all of those control plane services were deployed on a single VM. And what that means is you have to ensure that all the common dependency packages that are being used by various different services are compatible with each other. So on the node itself, you don't have any kind of isolations for the dependent packages. And anytime you would have to upgrade a single service, and if it have to update the dependency package that it's using, it might break the other services that are deployed there. So you don't want that. And that's one of the quite a huge pain point we had in the past. Whenever we would upgrade any service, we had to make sure all the dependency packages are also compatible with other services. Yaook solves this issue inherently because of containerization. So you don't have to take care of any conflicts, and you can upgrade your because each service is each of the services containerized. You can install any version of the service packages and services you would like. And that's about it for the problems we had. Some of it can be directly, we can say it's related to the salt, but most of it are can be seen in other configuration management tools as well. Just a brief outline of the Yaook project. We started it in summer 2020 in cooperation between STACKIT and Cloud&Heat. We entered productive use case on the STACKIT side starting September 2021. And yeah, so we deployed our Keystone and Cloud services then, and we by the beginning of 2022 we were fully running our OpenStack using Yaook. And if you would like to know more about the project, you can visit our website. You can check out the code that's on the GitLab. And if you would like to go more into detail of Yaook, of how it works, you can check out talk we presented at Open Infra Summit in 2022 in Berlin. And yeah, that's it. Thank you.
Thank you very much. And I think we are now open for questions if there are any.
Yes, exactly. Question time starts.
Yes, I would like to ask a question. This is Martin Pilka from D-Nation. Can you guys hear me?
Yes, we can hear you. Yeah.
Perfect. So my question is whether there are some kind of KPIs or any measurements how well the system performed before and after Yaook has been deployed. For example, the error rate or something.
Iti, do you have any? I'm not sure if you have any on your side. It's not like error rates before and after deployment. Though I'm not sure that error rate would be a perfectly great metric, but maybe maybe what a good metric would be the time you need to integrate new nodes into the cluster, because that level of automation is maybe something which Yaook brought.
I mean, from a subjective point of view, I would say we can definitely see improvements with maintenance of nodes that I described earlier. It's quite smooth compared to our previous solution that we were using. But we don't have any KPI for, let's say, how long it takes for us to deploy it or how efficient it makes our process.
I see. Thank you for your answer and for a nice presentation, by the way. It was very, very useful. The reason I'm asking these kind of questions because I'm preparing presentations myself, and I would like to promote ALASCA and as well Yaook. And the audience is kind of like going to ask this kind of question. It's very good that we do have a production installation. That's perfect. But if you guys could maybe after this call or later share some graphs or something that would really help me in my presentation. Thank you very much.
Are there further questions?
Yeah, this is Tor here from Cyprus. My question goes along a similar line. Entering productive use at STACKIT, what's the scale of this initial deployment? Are we talking one machine? Are we talking thousands? Can you give me, and I'm sure that's a little bit sort of secret, but can you give me a scale or an idea of how big this initial deployment really is?
Sure. So we have around 500 compute nodes.
Okay.
Yeah, and 4,000 projects. So and around 9,000 VMs that are running too.
And maybe what's important to point out is that it's generally accepted that you can't have an OpenStack cluster with more than 1,000 compute nodes. So even the large-scale special interest group of OpenStack, as far as I know, please correct me, E.T., if I'm wrong, is about if you need more than 1,000 compute nodes, you essentially will set up separate clusters because
that's right.
That is not going to scale because there are things inside OpenStack which don't scale that well. Maybe that will change in the future with some changes to the network layer in particular, but the general accepted limit is somewhere around 1,000 compute. So we are halfway there, right?
Yeah.
Thank you.
Any additional questions? Also in the chat, if you prefer to write them, then speak them up.
Well, I have another one, if I may. Following up from the last tech talk where we talked about test and test automation, how do you physically test this kind of infrastructure? Is it, do you have to are you doing a sort of complete deployment in order to test it, or do you have dummy infrastructure that you test the quality of the deployment and quality of the management? I mean, how do you do that?
So we have CI tests for every change, which include not only a considerable set of unit tests, but also a complete deployment of the OpenStack inside a virtual Kubernetes cluster. That OpenStack then runs through a series of smoke tests. We intend to integrate the official OpenStack test suite at some point later, but we will run into runtime issues there because the full test suite is expected to run over a day. And that's probably not viable for a CI test for every change. More something like we will run, more like something we will run before releases. But yeah, we do have extensive automated testing, of course, because otherwise that kind of project wouldn't be possible. You are muted, Tor.
Yes, I agree. Okay, well, it's very interesting. Jonas, you'll have to show me at some point how you do that. I'm very interested in that topic.
We can do that, sure. Basically, it's all GitLab CI. You can check that out in the repository. It's all public.
Yep.
Okay. Any other questions, comments? There was a comment in the chat, but I think it's what Martin mentioned before also when he was speaking. So
I can't see the chat while I'm screen sharing, so if you could read it out loud.
Yeah, no, he's asking for more information, but I think it's what he already asked you about,
Okay.
some relevant data and graphs. Okay.
Can you hear me?
Yes, we can hear you.
Yes.
Okay, yeah, here's Jan from Cloud&Heat. So I have another question for you. Ihtisham, is it right? Yeah.
Yeah.
You told us about the dependency breaks, which could be tackled by Yaook. Could you point out how directly does Yaook solve this issue for you?
Yeah. So all your OpenStack services are basically deployed in containers. And instead of being on an individual node or a VM. And for example, you have Keystone deployed on the same. Previously, what we had was you have Keystone and Noah API deployed on the same node. And they have some dependency packages, and they would have to be compatible. So if they have some common dependencies, you would have to make sure that this common dependency works with both of these Keystone and Noah versions. And in case of Yaook, you're running the Keystone API within a container. So you do not have any, it's very isolated. So you don't care, or no one else is using that packages that are installed in that container besides Keystone API itself. So you could be running package X with version 1, and on the Noah API container, you could be running package X with version 10 or something. So it's just Kubernetes inherently solves this problem for you, if that makes sense.
Yeah, yeah, okay, thank you.
I do have one more question, if I may. This is again Martin from the Nation. Can you guys hear me?
Yes.
Yes.
Yes, go
Yeah,
on.
I'm making sure, because sometimes, yeah, I'm on mute sometimes even if I don't want to be. Okay, so my question is, as we are running multiple Kubernetes clusters and we are experimenting with Yaook and OpenStack, we are facing this issue, and it's not in OpenStack world only, how to monitor all these. The tools which are there actually out of the box are not sufficient. So at the end, we decided that we are going to write something on our own, which we did, and we are actually successfully using it in production. However, it takes a lot of resources. So I'm wondering what you guys are using for especially monitoring Kubernetes, because as far as I understand, those are plain vanilla Kubernetes of OpenShift or something else. And also the same question that would be probably from Ihti. What are you using for monitoring your OpenStack instances? Thank you.
Jonas, you want to go ahead? Then
Yeah,
I can answer the second part.
Yeah, okay. So let me do the general stuff. So Yaook as an OpenStack lifecycle management tool is inherently tied to the, and now it gets a little bit more detailed technically, the service monitor resource of the Prometheus stack. So that is how we declare which endpoints you would want to scrape to collect monitoring data. And then it is somewhat out of the scope of Yaook how you actually collect that data. Obviously, the recommended way is to hook this up to some Prometheus instance, and then maybe some Thanos for long-time archiving, and of course a Grafana for dashboard and Alert Manager for alerting and that kind of stuff. By the way, for alerting rules, I would like to defer to the Sovereign Cloud Stack. There was some work on gathering alerting rules, and I think there's also some upstream project which gathers that, which you would then feed into your Prometheus for generating corresponding alerts. It is true that Prometheus needs lots of memory if you have lots of metrics. Yeah, that is definitely something you need to take into account when scaling, and especially with Kubernetes, you obviously have to take care not to ingest and archive every metric Kubernetes gives you forever, because you get a lot of metric churn that way.
Onto the second part of your question, we are using Prometheus. We are using Telegraph to push the matrix from the Kubernetes nodes to the Prometheus. And after Prometheus, we have Grafana, and we have Blood Manager, which takes care of what to do with these matrix.
Thank you for your answer. Just one follow-up question is that, yeah, that Prometheus and all that and all the memory requirements, we hit that issue. But the other issue we hit is that we couldn't find a good set of Grafana dashboards or something which would actually give us some meaningful view on top of those Prometheus data. And so do you guys have any suggestions what are you using here on as Grafana visualization?
You mean in particular for monitoring Kubernetes?
Both. Actually,
Okay.
we are in both. In Kubernetes, we kind of know how to do that, but it costs us a lot of resources. In OpenStack, we have no idea, basically.
Okay. So there is not yet a lot of, we want to make more of that public, at least. So there are some interesting metrics you only get out of OpenStack if you ask the database, basically. Like how many VMs are being created, how many VMs are even there. That kind of stuff you generally have to extract from the database, because if you do this via the API, you will just break the API and cause insane load if you do this at any monitoring rates. I know that there are query exporters running in on the STACKIT side, and I think there are plans to publish the queries for that and integrate them into Yaook.
Right.
Okay, thank you for the explanation.
That doesn't solve the dashboard issue, but at least you get metrics from which you can easier create your own dashboards. But actually, maybe having a repository with example Grafana dashboards would be a good thing. But I haven't actually thought about that yet.
Yeah, that's what I was thinking about, that to share this kind of thing, even, you know, we are using these Grafana dashboards. You can import them into your Grafana or something like that. It will be quite useful because what is there right now, it's not production ready. You have a lot of dashboards. They are serving a lot of data. You are basically lost. Anyway, thank you for your answers. It clarifies. Thanks.
No, but I definitely agree. Maybe we can push our Grafana dashboards. We had them for a while, and they're quite useful. So we can just push them to one of the Yaook GitLab repos to help others.
Final question from my side. Here's Tor again from Cyprus. The project was initiated in summer 2020. It's entered productive use. Is that the end of the story, or is there a roadmap of features and additions that are planned, or are you done?
We are not done.
And well, can you tell us a little bit about what the additional advances will be for the coming year?
So I think one of the major things currently going on is supporting more modern OpenStack versions, because we came from existing clusters and weren't able to run on the green field, which means that even today, Yaook supports OpenStack versions which have been end of life for quite a while. And we hope to get rid of that by mid of year, which is, of course, lots of work. Also work which has to happen outside of the code itself, because things need to be migrated and so on to more modern versions. And then those versions need to be supported in Yaook itself, which generally is not much work. There's a well-defined upgrade process from one version to the next, but you still need to do the, you need to implement the bits and take care of the rough edges and maybe some special upgrade steps. The other major bit going on is the scaling, really. I think STACKIT regularly hits one of the other scaling issue, which then is solved in the code. So, for instance, currently in work is performance improvement for the operator handling the compute nodes, because it became a little bit slow, taking, I think, what was it, hours for reconciling all the 400 something nodes?
Right.
Yeah.
So, I mean, and the more you increase the nodes, I mean, we need to find a good solution for that, which we are working on right now to improve, because the more custom resources you have, the more work it is for operator, even though we have parallelized it a bit by increasing some workers or runners, but we still have some way to go there.
Yeah, and aside from the technical scaling, there's of course also lots of improvements to the tooling to be had. So utilities for dealing with the daily problems you might encounter, repairing broken databases, for instance, when your node crashes or something like that. This kind of maintenance tooling and yeah, the fluff around the project, which makes it really fun to use. There are lots of open things to do there. And supporting more OpenStack services too. We still don't support some which are quite often asked for because we don't use them, but others do. So there's lots of playroom left, and it's definitely not done.
Thank you.
Last chance for a question or a comment. Okay, so thank you very much for the presentation. Thank you also very much for the questions and discussions. I will now share my screen again for some closing comments. So I hope you can see again my screen. The first thing is that if you have any ideas for a topic that would be suitable for a presentation as an ALASCA Tech-Talk, just send us an email. You have the email address here, hello@alaska.cloud. Even if you're not sure of whether the topic is the best one, or if you don't know what the best focus would be, or if you have any idea, just share it with us and we can help you figure out if it's the right idea, or if what the best focus would be for your topic. Yep. So just start thinking about it and let us know if anything comes up. Then, as I already mentioned, we have a section where we want to share events and news with you, and we want everyone to share events and news with each other. So if you also come across any event that you think would be interesting for the rest of the audience, just let us know either beforehand or let us know now. You can just open your microphone and let us know. We have here a couple of events that we have listed that we think would be relevant, and my colleague Ariane is going to say a couple of words on these events now.
Yes, exactly. I will do the start with the events. This is Ariane from Cloud&Heat. So the very first event is the FOSS Backstage 23. It's taking place in Berlin in March. And it's very exciting because we will be there with a couple of people of Community Square. Community Square is a very, very new, small initiative for open source community managers. It was kind of like, it happened accidentally because I'm the community manager of Yaook, and I was connected to Eduard, who is the community manager of the Sovereign Cloud Stack. And we also have Jan and Max from Uhuru Tech AG on board, who are also working on Yaook. And now we've just started to exchange ideas and best practices and also find answers to question about how you are a good community manager, what your tasks are, what challenges are, and it's really like learning from each other and growing together. And we had at the very beginning, so if you want to join, and just feel free to come and say hi. I will drop a link in the chat immediately. And yes, we will be at the FOSS Backstage and present this topic. And then the second event is obviously the Cloud Fest, also in March, in the Europa Park, and Alaska will be there. It's Alaska's first conference, and we are very excited and looking forward to meet everyone there.
Thank you. So does anyone have any events that they would like to share, or any news that might be interesting to everyone? If you have spontaneously any ideas, just let us know. Otherwise, for future tech talks, if you want us to put anything on the slides, then just let us know at least a few minutes beforehand. And otherwise, just always feel free to speak up if anything comes up. Okay, so only one more slide left. This is the save the date for the next Tech Talk, which will be on the 23rd of February. It's always on the last Thursday of the month, and it will be from 2 to 3 p.m. And there will be a talk by the Open Source Business Alliance with the title Joint Standardization in the Sovereign Cloud Stack Community. So that's the topic of the next Tech Talk. We're very excited to see and listen what the Open Source Business Alliance has to tell on this topic. And yeah, we will be very, very happy to see all of you back again here on the 23rd of February. Otherwise, if there are no additional remarks or comments, then we're done for today. Thank you again to the speakers for the great presentation. Thank you also for everyone to everyone for joining. And yeah, see you in a few weeks.
Thanks for having us. See you.